Imagine a sunrise, not on Earth but in space. A sunrise caused not by our sun but by a nuclear bomb. On July 9, 1962, the United States detonated a nuclear weapon 250 miles above the Pacific Ocean. This was Starfish Prime, a test that left its mark on both space and history. Why would anyone detonate a nuclear bomb in space? To understand, we need to go back to a time of great tension and competition, the Cold War. The Cold War was a time of distrust and rivalry between the United States and the Soviet Union. This period was marked by intense political and military tension, with both superpowers vying for global influence and dominance. The ideological battle between capitalism and communism fueled a relentless competition that permeated every aspect of life. Both countries were building up their nuclear arsenals, each trying to outdo the other. The threat of mutual assured destruction loomed large as both nations amassed enough nuclear weapons to obliterate each other many times over. This arms race created a constant state of fear and uncertainty, with the world watching anxiously. This competition extended beyond Earth into the realm of space. The vast unknown of space became the new frontier for demonstrating technological prowess and national superiority. The space race was not just about exploration, it was a battle for prestige and power on a cosmic scale. The space race was on. Both nations poured immense resources into their space programs, striving to achieve milestones that would secure their place in history. The race to the stars captivated the imagination of people around the world, symbolizing the limitless possibilities of human ingenuity. The Soviets had taken an early lead with the launch of Sputnik, the first artificial satellite. This historic achievement sent shockwaves through the United States, igniting a sense of urgency and determination to catch up. Sputnik's success was a clear demonstration of Soviet technological capability, challenging the US to respond. The US was playing catch-up, determined to prove its technological superiority. American scientists and engineers worked tirelessly, pushing the boundaries of innovation and engineering. The establishment of NASA marked a significant step in organizing and advancing the US space efforts. Against this backdrop of Cold War paranoia, the Starfish Prime test was conceived. This high-altitude nuclear test was part of a series of experiments aimed at understanding the effects of nuclear explosions in space. It was a bold and risky endeavor, reflecting the intense pressures and ambitions of the era. It was partly a show of force, but also an experiment to understand the effects of nuclear weapons in space. The Starfish Prime test illuminated the complexities and dangers of nuclear technology, highlighting the delicate balance of power and the far-reaching consequences of the Cold War rivalry. The test left a lasting impact on both scientific understanding and geopolitical dynamics. The Starfish Prime test occurred over the Johnston Atoll in the Pacific Ocean. A Thor rocket carrying a W-49 thermonuclear warhead blasted off into the night sky. High above Earth, the bomb detonated. The explosion created an artificial aurora borealis, visible for thousands of miles. The sky lit up with brilliant colors, a breathtaking yet terrifying display of human power. But the beauty was deceiving. This was no harmless light show. The blast had unleashed a wave of electromagnetic energy with unforeseen consequences. The Starfish Prime test yielded some startling data. Conducted on July 9, 1962, this high-altitude nuclear test was part of a series of experiments to understand the effects of nuclear explosions in space. The results were both fascinating and alarming, providing insights that have shaped our understanding of nuclear physics and space science. Here are 3 fascinating facts about the event that continue to intrigue scientists and historians alike. 1. Electromagnetic pulse, EMP. The explosion created a massive electromagnetic pulse that disrupted radio communications across the Pacific. This EMP was so powerful that it affected electronic systems thousands of miles away, showcasing the far-reaching impact of nuclear detonations in space. In Hawaii, streetlights went out and telephones went dead, hundreds of miles from the detonation point. The sudden blackout and communication breakdown highlighted the vulnerability of our infrastructure to such high-altitude nuclear events. 2. Artificial radiation belt. The blast created an artificial radiation belt around Earth. This belt, composed of high-energy electrons, encircled the planet and persisted for years, altering the natural radiation environment of space. This belt of high-energy particles persisted for years, damaging several satellites and posing a radiation hazard to astronauts. The unexpected creation of this radiation belt, led to significant advancements in our understanding of space weather and its effects on both human activities and technological systems. 3. The brightness of the explosion. The Starfish Prime explosion was visible from over 800 miles away. The sheer brightness of the detonation illuminated the night sky, making it one of the most visually striking nuclear tests ever conducted. Its brightness was far greater than anticipated, highlighting the immense energy released by a nuclear detonation. This unexpected intensity provided valuable data on the energy dynamics of nuclear explosions, contributing to our understanding of both their destructive power and their potential applications in space exploration and defense. Unintended consequences: a ripple through space. The Starfish Prime test was a stark reminder that actions in space have consequences, some of which we may not fully understand. The artificial radiation belt created by the blast posed a threat to satellites in future space missions. The EMP effect also raised concerns about the vulnerability of our technology to such events. Imagine a world where communication systems, power grids, and even our personal devices could be knocked out by a single high-altitude nuclear detonation. The shadow of Starfish, a lingering legacy. This chapter delves into the profound impact of one of the most significant events in the history of nuclear testing. The Starfish Prime test, conducted on July 9, 1962, was a turning point in the Cold War era. This high-altitude nuclear test was part of a series of tests designed to understand the effects of nuclear explosions in space. It highlighted the potential dangers of nuclear testing in space and spurred international efforts to limit such activities. The explosion created an artificial radiation belt, which had unforeseen consequences on satellites and space missions. The 1963 Limited Test Ban Treaty, signed by the US, USSR, and UK, banned nuclear weapon tests in the atmosphere, underwater, and outer space. This treaty was a monumental step towards curbing the nuclear arms race and protecting our planet from the devastating effects of nuclear fallout. The legacy of Starfish Prime is a reminder of the power we wield, the delicate balance of our planet, and the need for responsible conduct even in the vastness of space. It serves as a cautionary tale, urging us to consider the long-term consequences of our actions and to strive for a future where peace and cooperation prevail over conflict and destruction. As we venture further into space, the lessons of Starfish Prime become even more relevant. Space is not a limitless playground. It is a delicate ecosystem that demands our respect and care. The future of space exploration hinges on our ability to act responsibly, to prioritize cooperation over competition, and to ensure that our actions today do not jeopardize the dreams of future generations. The Starfish Prime test was a pivotal moment in the Cold War and a stark reminder of the power of nuclear weapons. What are your thoughts on this historical event? Do you believe that space should be a sanctuary, free from the threat of weapons? Share your thoughts and let's continue the conversation.